Okay, today's lesson is 4.4. We're going to prove triangle congruent by side, 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 okay? So what that means, if a triangle is congruent by side, 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 that three sides are congruent to three sides of another triangle. So I have these two triangles here, MNP and RQS. So if we use the situation here, it says if, right, we're going to go through this, if MN is congruent to QR, I'm going to give them one hash mark, okay? And then it says NP, segment NP is congruent to RS. So NP, I'm just going to put two hash marks. They're congruent to each other. And the last segment PM is congruent to SQ. I'm going to give that one 3 hash marks. Okay, so now all three sides of one triangle are congruent to three sides of another triangle. Then the triangle MNP is congruent, and sorry about my handwriting again, guys, to triangle QRS by side, side, side. Okay, so this is one of 5 congruencies that we're going to be talking about with triangles, but we're only going to be talking about side, side, side today. Okay? Now, here's some given information, right? It tells us that AB, the segment AB, is congruent to DB. So AB, DB. Then it also says AC is congruent to segment DC, or I'm going to give that one 2 hash marks. Okay, the only thing we're missing is this third side, but we talked about this, right? We know that BC is congruent to BC because it's reflexive. Okay, so I'm going to go ahead and give that 3 hash marks. So now all 3 sides are congruent to all 3 sides of the other triangle. So triangle ABC is congruent to triangle DBC by side, side, side. Okay, let's look at a couple more examples here, okay? So here's another similar like triangle that we have here. We have this given information that LM is congruent to LP and NP is congruent to NM. And we already know that LN is congruent to LN because it's reflexive. But we have to say that LN, this is another reason why, well, this is the last reason that we need all 3 sides to be congruent because we can't assume that something is congruent. So remember, this is reflexive. So now that we have all 3 sides, congruent to all 3 sides, you go ahead with your congruency statement. Triangle LMN is congruent to triangle LPN by side, side, side. Sorry about that, guys. The bell just keeps on ringing. All right, 2 more examples, I believe. Oh, just kidding. Maybe this is the last one. All right, so what I want you to do is graph the triangle, okay? So my first triangle, ABC, we're going to graph that here. So A is -7, 5, so -7, 5 is right here. Then B is -7, 0. That's going to be right on the x-axis. And then C is -4, 5. Right here. Okay, I am going to write the letters. A, B, C, and I'm going to do my best to connect my dots and make my triangle. Okay, so ABC is in pink. I'm going to do F, G, H in purple. Okay, so F is 6, 2. G is 1, 2, 1, 2. And H is 6, 5. Remember, we always do X first, right? 6, 5 is up here. Okay, now I'm going to, again, write my letters down so I know what I'm looking at here. So here we have F. This is G. And this is H up here. Connect my dots. All right, so let's see what we have. Remember, horizontal and vertical lines, you can go ahead and just count the units, okay? So if we start with AC is 1, 2, 3, right? And FH or HF is 1, 2, 3, that's also 3. So AC is congruent to FH. I don't know why it's not writing there. Okay, and then we can do the other line here. So AB is 1, 2, 3, 4, 5, that's 5. And FG is 1, 2, 3, 4, 5, also 5 units. So they are also congruent. I'm going to put a little hash mark here for the 3 and the 2 hash mark for the 5. All right, so we know that AB is congruent to FG because they have the same length, right? Now that works for horizontal and vertical lines. What we don't know is the length of BC. We need to find that out. So we're going to use the distance formula for that. So I'm doing BC, so we're using, oh, not A, you silly goose. I'm using B and C for my points. Remember, we subtract our x's, so -4 minus -7 is +7. All of that squared, plus 5 minus 0. All of that squared, and we just simplify down, right? This is BC. Sorry. -4 plus 7 is 3. 3 squared is 9. 5 minus 0 is 5. 5 squared is 25. I add these together and I get the square root of 34. If I try to simplify that, 34 is 2 and 17, so it really doesn't break down. So this BC is the square root of 34. That's how long it is. So we need GH to be the same length. So let's do GH here. So now I'm using G and H, these ordered pairs, right? We subtract, it's all underneath the square root. Subtract your x's, 6 minus 1, all of that squared, plus, subtract your y's, 5 minus 2, all of that squared. 6 minus 1 is 5, 5 squared is 25. 5 minus 2 is 3, 3 squared is 9. And 25 plus 9 is the square root of 34. Hallelujah! It's the same. So guess what? These triangles are congruent. So now we know that BC is congruent to GH. And therefore, triangle ABC is congruent to triangle FGH by the side method, right? All right, so it's not terrible, right? It's really nice if we have horizontal and vertical lines, but remember, you just use the distance formula for these ones that are diagonal, and you'll be just fine. If you want me to give you the distance formula again, I will. Remember, that is this guy right here, x2 minus x1, all of that squared, plus y2 minus y1, all of that squared. It's got a little messy here, sorry guys. All right, so that's the distance formula, or how to find the length. All right, so here's your assignment for today, number 20. I feel like that's not right. I think this is assignment 19. Sorry, guys. I think I wrote down the wrong thing, or maybe it is 20. All right, it's 20, just kidding. Page 234, 1 to 7, 9, 10, and 16. Look, there are not that many. I know you can do it. And don't forget about your IXLs if you didn't get those finished already. Have a great day. Bye.